आज ही डाउटनट ऐप डाउनलोड करें। डाउटनट पर होगा अब आपके सभी मैथ्स, केमिस्ट्री, फिजिक्स और बायोलॉजी डाउट्स का सफाया। बस अपने क्वेश्चन की फोटो खींचो, उसे क्रॉप करो और तुरंत वीडियो सोल्यूशन पाओ। डाउनलोड नाउ।
Guys, the question is a block of mass 10 kg is placed on a rough horizontal surface and is acted upon by a variable force F horizontally. The coefficient of friction between block and surface is mu. The force F starting from a value of 0 is increased linearly to 100 Newton in 4 seconds and then abruptly decreased to 40 Newton, which is continued for 3 seconds and then force is removed. We are given 4 options. Option A is the maximum velocity reached at by the blockage 5 meter per second. Option B is the time of motion of blockage 5.4 second. Option C is the maximum velocity reached by the blockage at time 2 second after the start of motion of the block. And option D is friction on block will be 25 Newton at time 1 second after the force begins to act. So we will solve every option one by one. So we will start as we have given. The block has mass 10 kg and a linear force F is acting. Friction coefficient mu is given 0.5. Now first we will calculate limiting friction, which is mu n. N will be 10 g, which will be 100 Newton. So limiting friction will be 0.5 into 100, which is 50 Newton. Now we will make graph between linear force and time. As given in the question, force is increased from 0 to 100 Newton linearly. So in 4 seconds, so it will be 4 seconds and it will be 100 Newton. And then abruptly decreased to 40 Newton, which is continued for 3 seconds. So 40 Newton continued for 3 seconds. Final time will be 7 seconds. And this is 40 Newton. Now till F equal to 50 Newton, friction will balance the force. Friction will balance the force. So till t equal to 2 seconds, there will be no motion and net force will be 0. So we will make graph including friction. As we know, till t equal to 2 seconds, net force will be 0, F net and t. And from t equal to 2 seconds to t equal to 4 seconds, t equal to 4 seconds, it will increase linearly and will go maximum up to 50 Newton. And then the force is 40 Newton and limiting friction is 50 Newton. So it will again balance and net force will be 0 till t equal to 7 seconds. As we know, at t equal to 2 seconds, there is no motion. Let at t equal to 4 seconds, velocity is v. Now impulse equal to pf minus pi, where p is momentum. First we will calculate impulse from t equal to 2 second to t equal to 4 second. Impulse will be the area between force and time. So area will be 1 by 2 this area. This length is 2 and this length is 50. So 50 and 4 minus 2 equal to 50. Now we have J equal to PF minus PI. As we know, PI equal to mV1 and V1 is 0 because there is no motion. So PI will be 0 and PF will be mV2, which will be 10 into V. So 50 equal to 10 V. V will be 5 meter per second. So option 1 is correct. V will be 5 meter per second maximum at t equal to 4 second. Now the second option is the time of motion is 5.4. So as we can see, minus 50 into t minus 7 equal to 0 minus 10 into 2. From here we will get 7.4 second total time. And time of motion will be 7.4 minus 2, which is for 5.4 second. Option B is correct. Option C is the maximum velocity reached by the block is at time 2 seconds after the start of motion. As we know, motion is starting at t equal to 2 seconds and V2 equal to 5 meter per second, which is maximum at t equal to 4 seconds. So the option C is correct. The maximum velocity reached by the block is after 2 seconds of motion starting. So delta t is 2. Option C is correct. And option D is friction on the block will be 25 Newton at time 1 second. So as we know from the question, F will be 25t at t equal to 1 second. Linear force will be 25 Newton and friction will balance it because maximum friction, limiting friction is 15 Newton. So to balance the F force 25 Newton, friction will be 25 Newton. So option D is also correct. Thank you.
क्लास 6 से 12 से लेके नीट IIT JEE मेंस और एडवांस के लेवल तक 10 मिलियन से ज़्यादा स्टूडेंट्स का भरोसा। आज ही डाउनलोड करें डाउटनेट ऐप या व्हाट्सएप कीजिए अपने डाउट्स 8400 400 400 पर।